Hey, welcome everyone to our annual Black Friday webcast where we get on. I was trying to remember how many years in a row we've done this. I'm guessing 5, maybe 6 years on Black Friday we've gone live and just did some free content, taught some free content. And one of the things we do, because it is Black Friday, we give some of our best deals of the year. The Black Friday Cyber Monday event, that's when we have the biggest sale of the year. And I want to let you know about some of those today. And as always, if you're attending with us live, you're going to hear a few special things that that maybe some of our other attendees aren't going to hear if they're watching on replay. But anyway, it's great to have you with us. My name's Kevin Wallace, and today the topic on hand is how to get your hands dirty with Cisco Modeling Labs and Cisco Packet Tracer. Because whether we're going after our CCNA, our CCNP Enterprise, we probably need some hands-on experience, don't we? So how can we get that? Well, we could go out to eBay and we could buy some live real gear and put that together in a home lab. And I've got nothing against that. I've done that. I've got a big rack of equipment. But here's a free option for us to have a fairly large topology, more than we might want to spend to build. If we just bought the equipment used off of eBay, we can build some really, really elaborate topologies using Cisco Packet Tracer and Cisco Modeling Labs. So today we're going to talk about each one. I'm going to show you how to get access to each for free. We're going to show you how to import an existing topology. In fact, let's just jump right into the agenda so I don't get ahead of myself. But again, I want to give you a big welcome. We've got people joining us from various channels. I've got 4 different chat windows up here, so I'll pre-apologize if I don't answer your question in a timely manner, because we've got people joining us on our website. We've got people joining us on YouTube, on LinkedIn, on our Facebook page. We will have some Q&A breaks during the session, so if you wouldn't mind, hold your questions for me. You can feel free to chat amongst yourselves, but hold any questions you have for me until one of those break times, because otherwise I'm just going to be completely distracted looking over here to see what questions have come in. I did see something come in just a moment ago that I wanted to share with everybody. I think it was, Tracy. Tracy said, just passed the ENCOR and taking the ENARSI exam soon. Congratulations, Tracy. That is fantastic. So glad our training helped you out with that. And hopefully we can help you get that ENARSI certification passed as well. But here's what's on tap for today. We're going to give you kind of an overview of what today is all about. If you're wondering about time, it's going to be about 2 hours or so is my guess. We'll take questions, so it might be a little bit longer, it might be a little bit shorter, just kind of depending on the volume of questions. And our first topic is Cisco Packet Tracer. And I'm curious, how many of you right now that are with us live, I'll post this replay later, but if you're with us live, how many of you are using Cisco Packet Tracer on a fairly regular basis? Just chat in if you would, yes or no. Yes, you're a user of Packet Tracer or not. And we're going to be talking about how to get access to it for free. Cisco gives it away to us. No weirdness going on. They just let us have it for free. Thank you, Cisco. We'll talk about how to import an existing topology. In fact, this blew me away when I found this out. The new version of the CCNA exam, it requires that you know how to configure, or the blueprint says you need to know how to configure a Cisco wireless LAN controller. Well, how do you get access to one of those? Well, Cisco Packet Tracer now gives you access to a virtualized, or to, I guess we would say, a simulated Cisco wireless LAN controller. I'm going to show you how to do that today, and I'm going to give you a link to download a Packet Tracer file that's got my base topology already in it. So you can just play with it and set it up and practice for your CCNA. I think you'll enjoy that. We'll build a topology, we'll build a switch topology, and we'll do a spanning tree exercise. So there'll be some instruction on spanning tree coming up today. We'll take a look at connecting a couple of routers and setting up a routing protocol. And because Packet Tracer is an emulator, it is not, or I said that backwards, it's a simulator, not an emulator. That means it's not exactly running Cisco iOS. It really seems like it is, but because it's just simulating Cisco iOS, there's 1 or 2 things that don't work perfect, and that's okay. You just need to know about them, and I'll show you 1 or 2 of those things that you need to keep an eye out for. And then, for those of you attending live, or if you're listening to this before our Black Friday Cyber Monday event ends on Monday, Then we'll give you some Black Friday / Cyber Monday offers you might want to take advantage of in our biggest event of the year. We'll take some Q&A, and then the last half of our class is going to be focused on Cisco Modeling Labs. And that is an emulator. It's running actual Cisco iOS on a variety of platforms. And while you can purchase it, that's what I do. I purchased it for $200, and I get 1 year's of access for that, and I love it. I'm a huge fan of Cisco Modeling Labs. But if you don't want to fork over the $200, you can go out to Cisco's DevNet Sandbox and access it for free. And you can reserve it in blocks of 4 hours at a time, and I'm going to show you how to do that. We're going to talk about how to import an existing topology, and I'll show you how to go get one of those that I've already created for you. And we'll build a topology from scratch. We're going to see how to connect through the application as well as your own terminal application. We'll do a basic router configuration. And one of the cool things about Cisco Modeling Labs, it's got all kinds of devices other than just switches and routers. You can have an Ubuntu Linux server as part of your topology. We're going to install that today. And I'm going to wow, I said 2 hours. I'm starting to wonder now if we can squeeze this into 2 hours. I'm going to show you how to get that Linux server set up, and we're going to take a look at some Linux commands, give you a little overview of Linux, take a look at how to edit a text file. We'll talk about Python a little bit because Python comes pre-installed on that Linux server. And we're actually going to write a Python program. If you're a programmer, you know, what's that first program you write in just about any programming language? It's, yeah, you know what it is? It's that Hello World program. We're going to write a Hello World program in Linux inside of Cisco Modeling Labs. Pretty cool stuff. And we're going to take a look at how to export a topology. This is one of the biggest questions I've seen so far. People will go out and I'll show them how to go out and get that 4 hour block of time where they reserve their equipment at the Cisco DevNet Sandbox. And they've got this really elaborate topology built up, and their time is about to expire. And they think, how do I save this? And they try to export it, and it doesn't work. It's not obvious how you export your current config. It's really not obvious, but I'm going to show you exactly how to do it today. And there's a new version that just came out a few weeks ago, version 2.1, and I'll be pointing out some of the new stuff there. And we'll give you one more opportunity to take advantage of the deals of the day, and there's going to be a special deal that I'm going to edit out of the replay. That's just for people attending for us live. So if you're live, you want to stay live to get that very limited time offer. And we'll wrap it up with some more Q&A. Now let's see how many people said that they were using Cisco Packet Tracer. Let's see. Yeah, we've got several. Let's see. I'm saying that we don't hear sound. Not hearing sound on, it looks like, our Facebook stream. 1 second here. Let's see. Let me just ask those people to please refresh, because we do have some people on Facebook that are hearing sound. So let's see. Some people use GNS. Yeah, there's EVE-NG, there's GNS3. But we could talk about a variety of things, but I'm going to talk about the two that Cisco offer today. Yeah, a lot of Packet Tracer fans out there. By the way, if you're brand new to me, if you kind of stumbled across this, you have no clue who I am, just a super quick bio. My name's Kevin Wallace, and I've got a couple of CCAs, one in enterprise infrastructure, one in collaboration. I've got one of those really early CCA numbers. My friend Keith Barker, he says, he gave me one of his OG of IT t-shirts. He said, yeah, Keith and I, we worked together like 2 decades ago. So we've been in this game for quite a while. And yeah, been doing this for many, many years. In fact, I started back in 1989 with Cisco gear. I worked on their very first router, the old Cisco AGS Plus, if anybody goes back that far. And I was a instructor with Cisco Learning Partners for about 14 years, and then decided, you know what, I want to create my own training company and create courses that I wish that I had. So that's kind of what I've been doing for the last over 6 years now. Real world experience includes being one of 5 network designers down at Walt Disney World in Florida. And I'm a huge Disney fan. In fact, I just remembered I'm wearing a Mickey shirt right now, but down at Disney World, I got to be the designer that designed the network that tied together the Magic Kingdom and Epcot and the studios and Animal Kingdom and a bunch of the resorts. And if you ever attend one of my live classes, we give you a lot of war stories from my time down at Disney World. That was a great experience. And I've written a bunch of books. I've lost count, honestly, maybe 16 or so for Cisco Press. Done a bunch of video courses for them. I've spoken at Cisco Live a couple of times. I was honored to get their Distinguished Speaker Award both times. All that, I'm not trying to say that from a boastful place. I just kind of want to let you know where I'm coming from and let you know that I'm passionate about this. And I have been for over 3 decades. And I am super excited to share this content with you because it's not been long since this was not possible to get free access to like emulators. So I think you're really going to enjoy today's session. And welcome everyone once again. Well, to access Cisco Packet Tracer for free, what you're going to do, and I've given you a shortcut link. You might want to jot this down. This is just a redirect from my website. And you go to kwtrain.com/PT for Packet Tracer, kwtrain.com/PT. That will redirect you to a Cisco Learning Network site, which will look like what you see on screen. And what you're going to be doing is actually registering for a course. Now, don't panic. This is not a course you have to pay for. It's not even a course you have to take. It's just the way you get Cisco Packet Tracer. And I've kind of circled on screen. You're going to say that you want to sign up for that course. And you do, and it's free again. And once you get in there, there's an option to launch your Packet Tracer course. And when you launch the course, one of the options is to look at your student resources. And one of those resources is the option to download and install the latest copy of Cisco Packet Tracer. So you go to that download page and just pick your operating system. Now, you can do this on Microsoft Windows. You can do this on Mac OS. I'm running it on Mac. I'm running Mac OS version of the version of Packet Tracer is 7.3.1. I've even got it installed on my It works a little bit differently, but I've even got it installed on my iPad, which is kind of fun to take with me on the go. But you're just going to go through that process, and you're going to get a free copy of Packet Tracer that you can run. Now, what I'm going to start out with today in our live demo is I'm going to show you how to set up a wireless LAN controller. This is very different than the Packet Tracer of just about a year or so ago. They really upgraded this. But if you want to get this .pkt file that you can install in your own environment, just go to bit.ly/ptconfig for Packet Tracer config. So bit.ly, that's bit.ly/ptconfig. Give you just a moment to jot that down. And as you do, I'm going to get my face out of the way because I want to go full screen and that was not what I meant to do. I want to go full screen so you can see all the little text on the screen. So I'll get my face off here. And if you've got that written down, let's go over to a copy of Packet Tracer that I've got running right now, shall we? Now, again, I'm running 7.3.1. I would recommend to update, especially if you're on Mac. I ran into a slight issue with the prior version, but 7.3.1, that's what I'm running right now. And let's take a look at that wireless LAN controller lab. So let's go open that up. I'll go into the File menu, and I will say Open, and I'm going to go to my desktop, and I got a folder there, WLC config. And here's our topology that we're going to be working with. I'm going to make this a little bit larger so we can see it better on screen. We can zoom in a little bit. But before I even talk about the different components on screen, notice the orange dots here. You know what that's representing? The spanning tree protocol state of this Cisco Catalyst switch. Because when you plug in devices into a port on a Cisco Catalyst switch, it wants to make sure you're not about to create some sort of a bridging loop. So it's going to go through the spanning tree protocol check, and we're going to actually teach you spanning tree protocol today if you're not familiar with it. But after about 30 seconds or so, not 50, we can talk about that later, it's 30, we're going to go active. And now we've got these green triangles to show that we are now active. So we got a switch in the middle. I've got a server over here that's acting as a DHCP server. It's also a web server. We're going to be doing our configuration from this PC, this admin PC. And we've got a wireless client. And I've got this I've got this wireless phone, like a smartphone, that we're going to be using to be our wireless client. Now, it's not happened yet because things are kind of still booting up in the background, but in a few moments, we're going to see lines, dashed lines going from this phone, the smartphone. Oh, it just happened as soon as I said it. I spoke it into existence. We're going to have lines going from the smartphone to the wireless access point. If we see those dashed lines like you do on screen right now, that means we do have a connection into the wireless network. And we're connecting, or we're going to go in and we're going to configure this wireless LAN controller over here, the Cisco wireless LAN controller. Because remember, you can run your wireless access points in a couple of modes. You can run them in autonomous mode, and that means that if you've got 5 different access points, you're going to be configuring those 5 different times. You're going to go to access point number 1, do a bunch of config. Go to access point number 2, do a bunch of config, and do that for every single access point and hope your configs match one another. Obviously, that's not scalable. So at the enterprise level, we want to create what's called a lightweight deployment, where we have a bunch of these lightweight access points, the LAP, if you can kind of see that on screen, and they're controlled by a single repository of the configuration information. It's this wireless LAN controller. Now, I say single, yes, you can have bigger networks that have more than one controller, but here we've got one wireless LAN controller, and I've already got it working on a wireless LAN, and the current SSID is CCNA. We're going to go change that, because if you're going for your CCNA certification right now, you're told that you need to be able to go in to a wireless LAN controller, configure a new wireless LAN ID. That's a new SSID. And here's specifically what the blueprint says. It says you need to be able to configure security for a pre-shared key, and you need to configure it for WPA2 running AES encryption. I'm going to show you exactly how to do that so you can practice this. First thing we're going to do is let's try to remember this. It's going to be admin, and the password is Cisco123 C. That's to log into the wireless LAN controller. So I'm going to go to the PC, and I'm going to go to desktop, and we're pretending we're on this PC, and there's a web browser. Now in this web browser, I'm going to say HTTPS. You've got to have the S or it's not going to work for you. HTTPS://172.16.1.150. And I press enter. And notice it gives me a login to what appears to be a Cisco wireless LAN controller. This is a simulated environment, folks. This still blows me away. The username we said was admin. The password was Cisco123 C, CISCO123. And I'll say login. Give it a moment. Oh, there we go. Click the wrong login. And just like that, look at that. In a simulated environment, this blows me away, that we're sitting virtually at a Cisco wireless LAN controller configuration screen. Now, because it's emulated, I said that backwards again, because it's simulated and not emulated, not everything is going to work. Some features are going to be grayed out, you'll notice, but it's going to do what we need to do for the CCNA exam anyway. I'll give you my tip for the CCNP exam coming up in just a bit. But for the CCNA exam, what we want to do is we want to go into the wireless LANs tab, and notice I've already got one wireless LAN. Well, the blueprint says we need to be able to create our own. So under create new, this little drop down menu, I'm going to say, yeah, I want to create a new one, and I'll say go. And for the profile name, I'll just say KW Train, and that's going to be our wireless network name as well. Our SSID, and I'm going to say apply. So we just created a brand new wireless LAN. Now, please hear me on this. Take a note, circle it. This is where so many students get tripped up. They set everything up and say, I'm not getting my dashed lines between my wireless LAN controller, or rather my wireless access point and my wireless device. It's because they didn't check enabled. You gotta check enable, so careful with that one. So we check that enable checkbox. And the CCNA blueprint says we need to be focused on security. So we're going to go under security, and we're going to be setting up some layer 2 security. So we're going to say WPA plus WPA2. And WPA is not what we want to use, but if you want to use either one, that's what you got to select. But notice, I'm going to select just the WPA2 policy, not WPA. I'm going to use AES encryption. That's what we're told. You could use TKIP, by the way, but I'm going to say I don't want to use .1x. That's something you need for your CCNP Enterprise cert. We're going to use, for the CCNA, we're going to use a pre-shared key. We'll say enable. And let's put in a key. Let's come up with something that I can easily remember and type in. Oh, how about this one? Not recommending this for the real world. I'm going to type in super secret key. I hope that I typed that accurately. And we'll say apply. And it just tells us, yeah, if you've got clients, they'll be disconnected during this. That's what you would normally get. So I think we're good. Let's go back to our wireless LANs tab, and it says, yeah, I've got this SSID of KW Train. It's enabled. I'm using WPA2 with the pre-shared key, and we saw that specifically the way I was doing WPA2, the encryption that I was using was the advanced encryption standard. Now, let's go over to our smartphone and configure it to use this different SSID. Right now, it's using the CCNA SSID. So what we're going to do instead is we're going to switch over to... let's see, I have to remind myself, what did I call it? Yeah, I call it KW Train. So let's go over to our wireless device. I'll go under Config, Wireless 2. Now, here's the way we set this up. Under Interface, we select Wireless 0. For the SSID, I'm going to change that to KWTRAIN. And for the security, I'm going to say, it's already selected by default. It's WPA PSK for Wi-Fi Protected Access version 2 pre-shared key. That's already selected for me. Awesome. I'm going to update the passphrase to super secret key. And notice that there's no apply button here on screen. It's not like, okay, save this, apply it. Because as soon as I enter it, it's automatically applied. And I may have killed enough time just chatting with you here to make it work. Let's go back out. Oh, look at that. It's already working. So we've got those dash lines. So that's showing us that we were able to set up a new SSID and set up security for it. That's what you need to do or need to know how to do according to the CCNA blueprint. Something else you need for the CCNA and for your CCNP studies is a knowledge of spanning tree protocol. And I particularly like the way that Cisco Packet Tracer handles spanning tree protocol because like we saw earlier, we can see if a port is forwarding or blocking. Notice the green arrows here. We're going to go, let's just create a new topology. Let's see here. I need to go full screen with that, and we'll say new. No, I don't want to save this. And we can build our own topology. Notice all these things that we can select from down below in the lower left-hand corner. We've got all kinds of network infrastructure devices. We've got endpoints. We've got all kinds of connections. You can play with a lot of stuff in here. We're going to keep it fairly basic. I'm going to say I want to select a switch. And we've got different switch models. I'm going to go with a layer 2 switch, a Cisco Catalyst. And again, I'll zoom in a bit. Let's go with the Cisco Catalyst 2960 series switch. Try to get that centered up and large where we can see it. Nice. And let's create a couple of other ones. I'll just make a little triangle topology with these. So we're going to have a switch, I'll call them SW1, SW2, and SW3. I'm going to go to the first one, I'll click it, and under config, let's see, I'm going to call it, I'll give it the name of SW1 as the display name and as the host name, SW1. And let's close that window. And notice it already says SW1 right there. Let's go to this other switch and do something similar. Under config, I'll say, you are SW2. And the host name is, you guessed it, SW2. And we'll close that, one switch to go. And it's going to be SW3. The host name is SW3. and we've got our switches at least named. Now we want to interconnect them. Here's the way you interconnect them. Notice the lightning bolt down here. If we click on that, we've got different types of connections. Normally, I'll just choose this lightning bolt, which automatically selects the appropriate type of connection. So I'll click that lightning bolt. I'll click on that top switch SW1, and I'll drag down to SW2, and I'll click, and that just created a link. Notice we're in the spanning tree blocking state right now, or at least we're transitioning to forwarding. Let's do it again. Let's create a link from SW1 down to SW3, and one more link from SW2 over to SW3. Now while this is coming to a steady state and everybody's getting active, what we can do here is just review how to do an analysis of a spanning tree protocol topology on paper. I just got a flashback when I said that. When I was interviewing for my network designer position down at Disney World, in my technical interview, I actually missed a question that you will not miss after this discussion. I thought I knew a spanning tree protocol, and they drew a topology up on a whiteboard, much more complicated than this. And they asked me to go to the whiteboard and tell them which ports were blocking. Well, I knew about root bridges and all that stuff and how that was calculated, and I thought that spanning tree protocol to prevent a layer 2 topological loop, I knew that it would block ports to prevent traffic from flowing over a link. But here's what I did not understand. Now, right now in this topology, we're not going to have traffic flowing over this link between SW1 and SW3. Notice we're blocking on SW3, so we're not forwarding traffic. What I didn't understand was I thought that if the link was not sending traffic, then both ends must be blocked. That's not true. Only one end on a link is blocked, and I didn't know that, and I missed that question. Fortunately, I still got the job, but I missed that question. Let's go through the 4 steps of MQC. I'm going to make a note right here. Here are the questions we're going to ask. We're going to say, I'll just number these. We'll say, number 1, who is the root bridge? And we'll define that for you. Question number 2 is, who are the root ports? And question 3 is, who are the designated ports? And question number 4, who are the blocking ports? All right. Those are the questions we want to answer. Now, if you're not familiar with spanning tree, let me bring you up to speed here. The root bridge, that's sort of that central point in the network that all the other switches point back to. Sort of like a tree in nature. You've got the root system and all the nutrients and everything kind of sprouts from the root system. Same thing here. All of the other switches are pointing back to the root as their best path, so that they don't have this loop which causes some really ugly side effects. But the root bridge is going to be the bridge, here for your notes, it's going to be the bridge that has the lowest bid, the lowest bridge ID. Now, the bridge ID is made up of a couple of components. It's made up of the bridge priority and the MAC address of the bridge. And I say bridge because it was developed in the days by Radio Perlman back in the 80s before we had switches. We had bridges, but they work basically the same, logically anyway. But we're going to say which switch has the lowest bridge priority. And I'm not going to change them, so they're going to be the default of 32.768. So it's a tie. What's the tiebreaker? The MAC address is the tiebreaker. So we're going to take a look at the MAC addresses of these switches, and whoever has the lowest MAC address, that's going to be our root. So check this out. Let's go into switch 1, and I'll go into my CLI, my command line interface, and I'm going to give this command. I'm going to say show spanning -tree, and it shows me my bridge ID. And here's my MAC address right there, so I'm going to copy that. It also shows me the MAC address of the root, and it's not us. So we know we're not the root. But I'm going to say, okay, for switch 1, I'll say the MAC is, and I'll just paste that in. So there's the MAC address for switch 1. Let's go to the same thing for switches 2 and 3, and then I want you to tell me who the root is. So let's go into switch 2, and just very quickly I'll do the same thing. Let's go to the CLI, and I'll say show spanning -tree. Oh, it says, well, this kind of gave it away, didn't it? This bridge is the root, it says, because notice the MAC address, it matches there. So I'm going to copy that. Let's go back to our topology. I'll create another note, and I'll say the MAC here is that. Now let's go get the MAC for switch 3. We'll go to the CLI again. And I'll say show spanning -tree. Let's copy its MAC address. And we'll complete our documentation here. We'll say MAC is that. Now, is that, we saw in the output, it kind of gave it away. I was going to ask you about it, but we were told that switch 2, SW2, that was the root. Well, if the bridge priorities are truly equal, 32.768 is the default, it's going to be the lowest MAC address. So this one starts with the 00016. This one starts with 0001C. Yeah, this is hex. 6 is less than C, so switch 2 has a lower MAC address than switch 1. The next one starts with the 006. Oh, already 006. Yeah, we're 000 here. So yeah, obviously, I hope you would agree that that this is the root. Now, I want to get your help with the in the live audience. I want to get your help with some of the others. Let me define a root port for you. A root port is the port, and only one port, on a non-root bridge. So the root bridge is not going to have any root ports. It's the port on a non-root bridge that's closest to the root in terms of cost. Cost is a function of bandwidth. And by default, if we're using these gig links, they're going to have a cost of 4. In fact, let me take you back over here and we'll see that. Oh, wait a minute. Are we using, it looks like we're using fast Ethernet, not gigs. Okay, forget what I said. We're going to use fast Ethernet. They have a cost of 19. They were a little bit slower. So every link's going to have a cost of 19. So I'll do the first one for you. The first one is going to be, I guess I should label our root, shouldn't I? I'll say, switch 2 is our root bridge. Now, there are no root ports on the root bridge. It's the port on every non-root bridge that's closest to the root in terms of cost. So let's go to switch SW1. We'll do this one together. Here, and this is fast Ethernet 0/1 on switch 1, it would have a cost of 19 to get to switch 2. It would go over one link, that's 19, because it's fast Ethernet. If it went to switch 3 and then over to switch 2, that would be a cost of 19 just to get to switch 3, and it would be an additional cost of 19 to get to switch 2. That's 19 plus 19. That'd be a cost of 38. Yeah, obviously, it's going to be shorter, and I'll label this. It's going to be more efficient to go out of fast Ethernet 0/1. So that's the root port for switch 1. Now, for switch 3, you tell me, is it fast Ethernet 0/2 that goes over to switch 2, or is it fast Ethernet 0/1? Whoop, didn't mean to disconnect that. Fast Ethernet 0/1, that's going to go up to, it's going to go up to switch 1. You tell me in the live audience. Go ahead and chat in. Is it FA 0/2 or FA 0/1? What do you think? Oh yeah, we've got some overachievers here. They're already kind of working out the whole topology here. Yeah, great job, everyone. Yeah, it would only be a cost of 19 to go directly over to switch 2. So yeah, just like SW1, we're going to have a root port that connects directly to the root bridge. Now, next up, we want to say who are the designated ports. And the designated ports are ports on every link. So please hear me on this. Every single port or every single link has one and only one designated port. Every link. whether it's forwarding traffic or not, it has a designated port. And it's the port on that link that's closest to the root in terms of cost. Well, let's take the two links going into the root bridge. Which one is closest to the root in terms of cost? The one sitting on the root bridge. This makes part of it pretty easy here. I'm going to say this is a root port, or excuse me, a designated port. I'll say DP for designated port. And it's going to be both of our ports on the root bridge are going to be designated ports because we don't get closer to the root than actually being on the root. But what about the link between SW1 and SW3? Well, if I were sitting on this end, if I were sitting on SW1, what's my cost to the root? 19. If I'm sitting on the other end, I'm sitting on SW3, what's my cost to the root? 19. What's the tiebreaker? The lowest, we're going to say, let's look at the two ends of this link, switch 1 and switch 3. Who has the lowest bid? Who has the lowest bridge ID? And is it 000 or 006? Yeah, switch 1 is going to have the lowest bridge ID because it's got the lowest MAC address and the priorities are equal. So that means this end is going to be a designated port. And the final question is who's blocking? And who's blocking, assuming the ports aren't administratively shut down, it's going to be whoever's left. And the only port that's left is this port off of gigabit, or rather off of switch 3. And you see what Packet Tracer did for us? It let us already visualize that. You see what it did? It showed us that this was orange. It showed that it was blocking. That's pretty cool. Oh, and if we actually want to see some packets in action, we've got a simulation button down at the bottom, and I'm going to say play, and you can actually see what messages are being sent between these switches. You can see when Spanning Tree sends like a bridge protocol data unit. It helps you really visualize some things. Now this is just Spanning Tree. On a routed topology, it's really cool because you can see things like Cisco Discovery Protocol, your OSPF hello messages. You can see your actual user traffic. Pretty cool stuff. In fact, well, I'll save that for Cisco Modeling Labs. But yeah, a really big fan of the simulator option. But that is a look at how we can use Cisco Packet Tracer. Again, if you want to go out and get that file that I began with, I'll write it for you here on the screen one more time. It was bit.ly/pt config, and that's going to let you download a .pkt file that will have that topology where we worked on the wireless LAN controller. So that, my friends, that is a look at Cisco Packet Tracer. And I know we've got a lot of Packet Tracer fans in the audience here. And I do want to take some questions. You just saw a preview of Cisco Modeling Labs there. But I do want to take some questions after we've completed this demo. Oh, I promised you something else. I forgot. I said, if you're going for your CCNA, because now things aren't just route switch focused, they're enterprise focused. And there are a lot of other technologies, like wireless is a big one. There's wireless, there is security, there's programmability, cloud. There's a lot more than just route switch. And one of the big things that there's a much larger emphasis on at both the CCNA and the CCNP level is wireless. What if you want to practice some more advanced wireless things that would not be supported in Cisco Packet Tracer? Well, I kind of stumbled upon this, and I think you're going to love it if you're going for your CCNP, because this is Cisco gives us a 60-day evaluation. So you're not going to use this in production because it expires, but they give us a 60-day evaluation of a virtual wireless LAN controller. And I mean, it's like a full-featured wireless LAN controller. It supports something like 3,000 access points. It's amazing. And you got a 60-day eval. You've got to have a Cisco login, cisco.com login, which are free. To my knowledge, you don't have to have any special permission with your login. You don't have to have a SmartNet contract or anything. So I've given you a link to direct you to that page. It's bit.ly/WLC download. Now, please hear me on this. You're going to see a lot of things to download. And before you can see what you're allowed to download, you've got to log in. So you must log in at this point. And once you log in, you're going to see that there's only one thing that you can download, and I've highlighted it for you here on screen. It's the Cisco Wireless LAN large-scale virtual controller. And it says it's got a 60-day license. It's an ISO file, so you're going to install this in your... I've personally got it installed in ESXi, running on a server that I use for a bunch of images, a bunch of virtual machines. I've also installed it on VMware Fusion, running on Mac OS, which now is free for personal use. VMware Fusion is, which is kind of cool. When you're setting it up, you're thinking, okay, what operating system should I set? How many processors and all that? This is not from a documentation. This is what worked for me. If you want to jot this down or take a screenshot, I set it up to be the Linux Cent OS version 4.5 or later, a 64-bit version, a couple of cores, a couple of CPUs, 8 gig of memory, and 8 gig of hard drive space. And that's what I use when we teach our wireless training at the NP level. It is full featured. It's very, very, very cool. But all right, now that we've taken a look at some student questions there behind the scenes, let's get into our next big topic, and that is Cisco Modeling Labs, or CML. Specifically, CML Personal Edition. There is an Enterprise Edition, but Personal Edition, that's what most certification candidates are going after. And when I'm recording this, it's just been a few weeks since CML version 2.1 came out. And I purchased it. Well, I already purchased 2.0, so I got the free upgrade to 2.1. But it's about $200, and I think it's well worth it. But if you don't want to spend that, there's a way to go out and get access to it for free at the Cisco DevNet Sandbox. So let's talk about some ways that we can get access to Cisco Modeling Labs. And I created a shortcut link for you to take you to their DevNet Sandbox lab for CML. Now, again, you got to be able to log in through. I think they allow you to log in maybe using Facebook or Google credentials even. They might not even require that you use your Cisco credentials, but once you get logged in, let's see, I guess that timed out. Let me try that again here. I'm going to open that up in a separate browser window. Give me 1 second while I do that. One second, folks. I had it all up before class and then it timed out on me. Let's see, it's going to be bit.ly/CML Sandbox. And I'm going to get logged in here in the background. All right, and here's what it looks like. Once you get logged in, it's going to look something like this. You're going to have Cisco Modeling Labs running, and you can access this over a VPN and do the administration as we're going to be doing. You can do this virtually using your browser going over the VPN, and it gives you instruction on how to get your VPN access. You can even download the VPN client software, the Cisco AnyConnect client. And they give you a very robust topology to start with. This is what they've got all interconnected for you to begin with. However, most people, they'll want to just go in here and stop that lab altogether. I think it's like 14 devices, so it's really consuming the number of devices you can have. What I'll normally do, I'll just stop that, and I'll create a brand new lab, which I'll either import something, or I'll create my own lab from there. But again, you can just use that link. Use that link to get there. And that is bit.ly/CML Sandbox. Or if you want to purchase it, you can go, and I created a link for you for this as well. It's bit.ly/buy CML. Buy CML. And here's what that looks like. There are actually, as of version 2.1, they added a new option. When I first bought it, there was only one option. It was the personal version, and that gave you 20 nodes. A lot of people going after their CCNP, or excuse me, CCIE in enterprise infrastructure, they need more nodes. So now you can get Personal Plus, which gives you 40 nodes. 40 nodes, that's pretty cool. For most of our CCNP studies, though, I'm fine with 20 nodes. Now Charles, he'll probably want that Personal Plus because he's studying for his IE right now. And yeah, when I took my first IE, this was not on the radar. I had to just go out and I bought a bunch of, I begged, borrowed, and stole. I didn't steal, but I begged and borrowed, and I purchased some of my own physical gear to build my home lab. But now, hey, look at this. You can do this virtually for just a few $100s. I paid thousands for my gear. But that's how you can buy it. And the advantage of buying it is you can use it whenever you want, for as long as you want, well, up to a year. If you use the DevNet Sandbox, you can reserve a block of time if it's available then, but that block of time maxes out at 4 hours. Now, yeah, you can export your config, start a new session for another 4 hours. Most of the stuff you're going to do probably is not going to take over 4 hours, so that might be a viable option for you. But I wanted you to know what options you have. But what we're going to do is I'm going to demonstrate this on my local gear. I've got my local version of CML running, and I'm running this on the VMware ESXi software. And I have run it on VMware Fusion on the computer that I use to teach class. But because it puts a processor burden on that, it's the same processor that I'm using to stream my video. I'm streaming in 1080p right now. So it was really bogging down my computer when I was running like 16 emulated devices plus streaming at 1080p and doing lots of other things, lots of other windows up. So yeah, I decided to put it on an external server, which we can just access over a browser. And let's see, here it is. This is Cisco Modeling Labs version 2.1. And again, I'm going to take my face off so you can see this a little larger on screen. And the first thing we want to do here is, well, let me kind of set the stage first. When would you use this versus when would you use Cisco Modeling Labs? Well, I think I mentioned Cisco Modeling Labs will do what you need to do, I think, for your entire CCNA studies. That's what you need. When you're in your CCNP studies, though, or your CCIE, I'm a huge fan of using Cisco Modeling Labs instead. Because here, we're not doing simulations, we're doing emulations. And an emulator is actually running Cisco iOS. So there was some stuff in Cisco Packet Tracer. We didn't do the, I meant to do a router thing. I looked at the time. I didn't want to keep you here too long. I was going to show you a router config, but we can do something similar here in CML. And I was going to show you when you're setting up OSPF, there's a shortcut that I normally take that you're not able to take where you can say the network is all zeros and that makes every active interface participate in OSPF. Yeah, you cannot do that in Cisco Packet Tracer because they didn't really add that on when they were doing the simulation. But because we're running Cisco iOS software here in Cisco Modeling Labs, yeah, we can do it here. Now, I want to show you how we can import an existing lab, and I want to tell you how you can go get this lab if you want to play with this one on your own. But if I want to import an existing lab, it's a .yaml file, .yaml. If you've worked with Ansible as a software deployment tool, that also uses YAML. YAML stands for YAML ain't markup language. Besides the grammatical issues there, I just think that's a weird thing to call it. YAML ain't markup language. That's what YAML literally stands for. I had trouble believing that for a long time, but I've checked source after source. That's really what it stands for. But here's how we do that. I'm going to go up and I'm going to say, actually, not from my browser. I'm going to say import. There's an import button here. And I'm going to say, yeah, I want to import. And I'm going to pick this OSPF troubleshooting.yaml file that you see. Now, if you want to get this file for yourself, here's what you can do. Write this down. I don't have a link for you, but write this down if you would. I want you to go out to YouTube. It's on my YouTube channel. Just go out to YouTube and search. Do a search on YouTube for Kevin Wallace OSPF troubleshooting. Kevin Wallace, OSPF troubleshooting. And there'll be a video that you'll find that I did where I'm doing a troubleshooting lab on Cisco Modeling Labs for OSPF. And in the description of that video, there's a link to download this, what I'm about to download. So you can go get this OSPF troubleshooting.yaml file. Just go to that YouTube link, look in the description, and there's a link for you to download this. Now I'm going to say, yeah, I want to import that. And it says, all right, we've imported it. Let's go to the lab. So here we are at that lab. It's got, looks like we've got a couple of switches. We've got a couple of, we've got 3 routers. We can zoom in a little bit. But there's the topology that we have. Now, it's not currently running. Here's one way we can start this. Under the Simulate tab, I can say, Start Lab. And notice we'll get, it almost looks like the little recycle symbol. I don't know if you can see it here, but it's like a little spinning arrows. When these devices have booted up, then we'll be able to see that, yeah, they're up because there'll be a green dot next to them right there. But yeah, you can just import these .yaml files to get some really elaborate topologies that you can work with over and over again. But while that's booting up, I wanted to show you how we can create our own topology. So I'm going to go back to the dashboard, and there are so many things you can do with this. There are so many devices that it is going to emulate. And I'm going to create our own. I'm going to say I want to add a lab. And notice we've got all these different nodes on the side that we can select from. There's more than this. These are just the ones that I've enabled. Let's create a fairly simple topology, but I want to show you how we can do some Linux stuff as well, which is kind of cool. I'm going to put a layer 2 switch in the middle. That'll be my Cisco Catalyst layer 2 switch. Let's put just a regular Cisco IOS router connected to it. I want to get that Ubuntu server connected in, so I'll click and drag that over, or click it. There it is, and drag that over. And I love this, the external connector, the cloud. Now what this external connector does, let me see if I can zoom in a little bit so you can see this better. That looks better. This external connector allows this emulated environment to go out to the rest of the world. Because my server that's running ESXi, it's got a connection out to my home network, which of course gets out to the internet. So what it's going to do, it's going to act sort of as a router. It's going to do NAT, it's going to do network address translation, and it's going to act as a DHCP server. So these devices, for example, when this Ubuntu Linux server boots up, it's going to go out with DHCP and say, hey, can I have an IP address? And this cloud icon is going to give it an IP address. Kind of cool. And it's going to do natting from this private IP address space that it's going to be handing out addresses for. It's going to NAT between that and my home network, which is then going to get us out to the internet. So we'll be able to connect to Cisco.com from this emulated lab. That still blows me away. So let me do some connections here. Here's the way the connections are going to work. If I hover over this, notice that there's a little play button. That's how you start this device. There's also these links. It looks like a couple of chain links. I'm going to click on that link, and I'm going to drag this line over to my switch, and I'm going to release. And it says, all right, what interfaces are we going to be using here? Well, I'll use gigabit 0/0 on my router and 0/0 on my switch. I'll just say, all right, let's create that link. Let's create a link between our Ubuntu server and our switch. And I'll just take the default ports that it suggests. And now I'll go from my switch out to that external connector cloud that's going to get me out to the rest of the world. Now, I want to start these devices, so the way I'm going to do that is, I'll show you a couple ways to do this. One way we can do this is I'm going to go under Simulate, and I'm going to say Start Lab. And notice we get the little spinning arrows to indicate these are booting up. It's going to take just a few moments for it to do that. While those are booting up, I want to show you how we can get a console connection into these guys. So let's go back to the dashboard. Go back to the dashboard, and here's that lab I created. I'm going to change the name, by the way. I'm going to change the name to, we'll say CML Demo. And we'll press enter there. But let me show you how to get connected to one of these OSPF devices that we've already got booted up. Because notice they now have the green dots next to them indicating that they're booted up. One way to do it is within CML itself. If I want to go to R2, I can notice that there's this little console icon on the right of the circle. If I click on that, it gives me an option down below, and I can click and drag to make the screen larger. It says click this to open the console. So now I'm sitting at the console of router R2 with its configuration. I can do a show IP OSPF neighbor command, and I don't have neighbors. That's a problem, and that's what you're going to be troubleshooting in that lab if you go check out that YouTube video and download that file. But the point is, this is one way of getting console access. Now, what was a bit of a disappointment to many people is early on, the thought was, in fact, I've heard that Cisco had planned on giving us sort of like a tabbed interface so I can have all my consoles open at one time, and I could just go from one to the other without having to actually navigate and say, open this console and open this console. And they actually came up with a way of doing that. You would open a separate window and you had to go to a special URL. In the beta version of the software, version 2.1, there was a way to get multiple consoles, but it didn't make it into the final release, unfortunately. So we still have to just, if I want to go to R1, I then have to go to R1, click the console, click open console, and then work from there. I much prefer a tabbed interface. So let me show you another way of connecting in to these devices. And I'm going to do that from just my Mac terminal screen. Now, by the way, if you're on Microsoft Windows, there's you can go out to the Microsoft Store and there's a free application just called Windows Terminal that does something very similar. But here I'm on Mac OS and I'm going to be using the built-in terminal application. And I'm going to do a secure shell over to my CML server, which is at 172.16.222.222. And let me get logged in. And when I get logged in, assuming I entered the password correctly. Oh, no, I did not. Try that again. Now that's curious. Let me be very careful in my typing here. Okay, I must have mistyped it twice in a row, but at least we're in there now. We're at this consoles prompt. And if I do a list, I can see all the devices that are running on CML. The CML demo that we just created and booted up, we see those here. This OSPF troubleshooting, we see those here. Well, if I want to connect to, let's say, router R1 as part of this troubleshooting lab, notice that all of the OSPF troubleshooting labs, they've got the same lab ID. So I'm going to highlight and copy the lab ID, and to go to router R1, that's going to be node 2. And notice there are a couple of ports I can connect into the router. If you've looked at a physical router, it has a console port and an auxiliary port. A switch will typically just have oftentimes a switch will just have a console port and no auxiliary port. But sometimes you might find them that do. These actually do have that extra port. But I'm going to say I want to open / I'll paste in the lab ID / I'll give the node of N2 / and I'll give the 0 for the console port. And it says we're opening the console for R1. And I'm sitting at the R1 prompt. I can do a show run. So what I will do here in Windows Terminal, I'm going to do it's a Command-Shift-I. If you're, I'm sorry, not Windows, my Mac terminal. If you're a Mac user, it's Command-Shift-I, and I'll give it a name of R1. And I can open up a separate tab. I can say, give me a new tab. And I'll name this one R2. And I won't go through all these. I just want to show you how we can have the tabbed interface. I'll log in again. typed it accurately that time. That's great. And I'm going to say open, and I'll paste in the lab ID. This time I'm going to go for node 3, that's R2. The 0 is the console port, and now I'm on R2. Now notice this, I've got an R2 tab, an R1 tab. I can have tab after tab after tab. In some of my live training, I've got like 14 tabs going at once. So I personally am a big fan of using this interface as opposed to the one at a time interface that we have here. Now let's go see if our topology has booted up yet. Let's go back to the dashboard, and let's see if we're good to go on our CML demo topology. Let's click into it. Does everybody have a green dot? I think they do. Let me zoom in here so we can see it better. Everybody has green dots. Let's do this. Let's go to R1. Let's call this, here's how you change the name, by the way. Let's click on the router, and we're going to just change the node name to R1 and press enter, and that changes the node name. I'm going to call this Ubuntu server. Let's click on that. I'm going to call it just Linux server. I'll take our switch and I'll call it SW1. Press enter. And I'll take our cloud and I'll call it internet. Now let's go into R1. And you know what? I don't want to do it with a little fine print here. I'm going to do, I said I preferred to do it this way, so I'm going to do it this way. Let's create another tab here. And I'm going to call this one, this is going to be demo R1. Let's do a list. We're going to have a different lab ID this time. Let's see, this is going to be my iOS V router. I'm going to copy paste the lab ID. It's going to be node 1, console port. No, I don't want to enter the initial configuration dialog. That's going to take a moment to boot up. So I'm going to create another tab. And for this one, I'll just name it Linux. And let's get connected here. We'll do a list, and we'll open the same lab ID this time, the Linux server. That's our Ubuntu server, node 2. Notice it does not have an auxiliary port, so it's just going to be one port that we're going to connect in with. And here's the login. Yeah, if you play with this, the default username and password is Ubuntu. Password is Cisco. And we're logged in. How cool is that? Now let's do a little configuration on our router if it's already up and ready to go. It's close. There we go. Here's some things I like to do on a new router config. I'll just give you some of my own best practices while we're talking about it. I like to go into my console line. I'll say line console, and if I'm going to be secure shelling into this, I might do it for my VTY lines as well. But here's one of my favorite commands. I like to say logging synchronous. Logging synchronous. What does this do? Have you ever been typing a command and some syslog message just rudely pops up on your screen and says, this event happened, and it pops up right in the middle of what you're typing in. It just totally messes up what you're trying to enter, and you're like, where did I leave off? If you say logging synchronous, if you do get rudely interrupted by one of those syslog messages that pop up on your screen, it's going to take whatever you've already typed, and it's going to nicely place it on the next line, so you can just resume typing. It doesn't interrupt you, so big fan of that one. I also like to say exec timeout. Now, I do this just for a lab environment. Hear me on that one. But for a lab environment, I would recommend doing this. Exec timeout 00. That means we're not going to time out. Now, let's go back to global configuration mode. And if I'm not going to be using a DNS server, I would say no IP domain lookup. That is very handy if you're not using a DNS server, because if you mistype some sort of a Cisco iOS command, it's going to waste a bunch of time saying, all right, looking up show spelled incorrectly, because it thinks you're trying to type in a Cisco iOS command, or Thinks you're trying to type in a DNS name when you're just mistyped a iOS command. So by saying no IP domain lookup, it won't do that. In this example, I actually do want to do a domain lookup, so I'm not going to say that. In fact, I'm going to say my name server, IP name server, we'll use one of Google's freely available servers of 8.8.8.8. And I'm going to go into, let's change the host name. I'll say the host name is R1. And I'll say my IP address. Actually, no, let's go into gigabit 0/0. That's the interface that we're using to connect into the switch. I want to use DHCP because that cloud icon, it's going to give me IP address via DHCP, which is pretty cool. I'm going to say IP address DHCP. And I'm going to do a no shutdown to administratively bring that up. Let's wait about 10 seconds here, and we should see that we get magically assigned an IP address. Let's see if that works out for us. Give it just a few more seconds. Feel like humming Jeopardy music right now. There it is. It took about maybe 15 seconds. But it says we just got assigned the address of 192.168.255.159. We can verify that by doing a show IP interface brief command. Look at that. We've got an IP address. I didn't enter that. I just said use DHCP, and it automatically learned it from that cloud icon. Does that mean I can get out to the rest of the world? Let's see if I can ping Cisco.com. Look at that. I was able to ping Cisco.com from an emulated router. That's amazing to me because that was just unthinkable a few years ago. Now I want to show you something that just gets people very confused. I'm going to save my configuration. I'm going to do a copy, run, star, and I have saved my configuration. So I'm going to circle back to this in a few minutes. I want you to remember though, I have saved my configuration. But I want to do some more configuration before I show you the issue that we're going to fix. I want to go over to my Linux server now. And how many people have worked with Linux here in the live audience? Just give me kind of a yes or a no, or maybe a little bit. Or maybe you can say, yeah, I'm an expert in Linux. Where do we stand on Linux? Oh, somebody was asking when the IT Insider takes place. That's our monthly membership program. Yeah, it's usually Thursdays at 2 p.m. Let's see. Okay, we've got a variety of Linux experience joining us today. We've got some yeses and some nos. We got a little bit. All right, let me I don't want to give you an in-depth. See, this used to be my jam. For years back in the early 90s, I just lived and breathed Unix, the predecessor to Linux, and I love this stuff. But let me just give you a few handy commands. For example, if you're familiar with MS-DOS, and that's kind of getting a lot of people are not knowing how to use that any longer either. But in MS-DOS, if you wanted to see what directory you were in, you would say something like CD, and it would tell you. But here I'm going to do a PWD. That's present working directory. I'm in the /home/Ubuntu directory. And if I want to make a directory, I can say mkdir, and let's just call it Kevin. If I want to see what files or directories I have, I can do an ls. I like to add the -l qualifier to make it to give me some additional information. I've got this thing called Kevin, and you see this D right there? That means it's a directory, and I can go into that directory. I can say cd Kevin ls. There's nothing here, but my present working directory is now home Ubuntu Kevin. I can do a cd ... to get back up to that parent directory. And then if I want to remove that directory, I can say rmdir Kevin. And that removes it, and we see now it is gone. Let's create a text file. There are different ways, there are different editors you can use to create a text file. I'm a little bit old school on this. I like to use the VI editor that's been around for decades. I'm going to say VI text file. And I'm going to say I for insert, and I'll just do something really simple. I'll say this is a Unix-based text editor. I'll do an escape to get out of insert mode. I'll do a :WQ to write and quit. And now if I do an ls-l, look at this. I've got this text file that says text file. Now notice the permissions we have here. There's no D in the first field, so it's not a directory. But notice we've got RW dash, RW dash, R dash dash. Well, we've got 3 sets of permissions there. And those could be RWX. If this were an executable file, and this is not, that would be an execute. It could be RWX for execute, where we could run some application or run some program we wrote. Right now, it says RWX. That's for the owner. The owner can read and write. The owner, and I'm the owner, Ubuntu, and I'm a member of the group Ubuntu as well. The group permissions are next, RW, and the public group is next. They can just read, they cannot write. So if this were, just for fun, let's say this were an executable file, I could do a change mode, and I could say +X. I need to say what the file is though. Text file. And now if I do an ls-l, notice I've added the execute option to all that. Now if I want to get rid of that file, I can just do I can say rm. Oh, if I want to see the contents of the text file, I can say more text file. And it says this is a Unix-based text editor. And I can say rm text file if I want to get rid of it. And we see it's now gone. Something else that is super cool, especially since programmability is becoming such a big deal these days in Cisco certifications, we're going to say that we might want to write some Python programs. Python is built in. I love it. If I say Python, it says it's trying to run an older version, so we need to specifically say Python 3. I'll say Python 3, and notice we're at this 3 greater than sign prompt. That's our Python prompt. Now we can do quite a bit of stuff from here. For example, this is it's great for mathematics. If I want to do 5 times 7, I'll just do 5 star 7, 35. Spaces do not matter. I could do 2 space minus space 4, and it's going to say -2. If I want to do oh, here's a fun one. Let's assign a variable. I'll say x equals 5, and then I'll say give me 6 times x. So that should be a 30, and it is. Now those are all just integer data types. We've got other data types. We've got floating point variables. We've got names. Or excuse me, we've got strings. In fact, check this out. I want to say my name equals, and this is going to be a string variable, so I'll put it in quotes. I'll say my name is Kevin. What do you think would happen if I did 4 times name? It shows my name 4 times. I think that's kind of cool. Now, if I want to exit this, I'll say exit, but I'll get an error if I press enter now. If I just press enter, it says, no, you have to use a function to get out of this. So I need to say exit, open parentheses, close parentheses, because that is a function. Now, what I want to do now is take what we've talked about with VI, our editor, and Python, and let's write a basic Python program. One of the first programs we write when we're learning a new programming language is oftentimes we'll write the Hello World program. Let's do that. Let's say VI. We'll say VI, and we'll just call it hello world.py. I'll say hello world.py for Python. By the way, notice I capitalized the W. I did not capitalize the H. This is a common naming convention used by programmers. Some people call it camel case because it, like the camels, it's big in the middle. In other words, when you're sort of mushing different words together, you don't capitalize the first letter of the first word, but you do capitalize the first letter of subsequent words. That's the reason that the W is capitalized and the H is not. But let's go in and edit this file. I'll press I to insert, or I could do A to append. And I'm going to say there's a variable, a string variable called greeting, and it equals the string of hello. And I'll put that in quotes. Let's create a string to represent a space. I'm going to say a space equals quote, space, close quote. And let's use the print function. I'm going to say I want to print the variable value of greeting, which we know is going to be the word hello, plus whatever the variable space contains, which contains the string of a space. And to that, I can add the string right in here. I can say I want to add to that world. And I'll give an exclamation point and then a closed parentheses. Just a really, really simple program to say hello world. I'll do a colon right quit. And here's what the program looks like. I'll say more hello world.py, and it shows me our configuration, but let's run it. The way we run it is I say Python 3 hello world.py, and it prints on screen hello world. We just wrote for what many of you might be your first Python program. And the reason I think this is so powerful, you might say, what is the big deal? We've got Python within Cisco Modeling Labs. What are we going to use that for? Well, let me show you. If I go back to, actually, I'm just going to go add nodes. Now, this would require a much deeper discussion in network programmability and API calls and things like netconf and restconf, stuff we talk about in the ENCOR course, by the way. If we added this guy, if we added a CSR 1000V, and we won't take time to do that today. I told you I'd try to keep this to less than 2 hours. But if I added a CSR 1000V, let's see, I need to make this a little bit smaller. What it would do is allow me to write Python programs that would interact with that CSR 1000V. Go ahead and create that link. Because I could send API calls to that. I could send get messages or put or post or different HTTP verbs. These are called, this is called REST communication, representational state transfer. I could write a program, bottom line, I could write a program that would reach up using Python. It would reach up to that CSR 1000V. It could pull down an existing configuration. I could do a configuration within Python or within a file that's going to be read by Python, and then push that configuration out to the CSR 1000V. I could do network programmability inside of Cisco Modeling Labs. Now, let me show you, which I think that's one of the reasons that this excites me so much. I'm a huge fan of Cisco Modeling Labs. But before we conclude, I wanted to show you one of the most challenging aspects of Cisco Modeling Labs, and it's this. Let's say that I want to save this configuration. We think, well, that's cool. I want to come back to this later and continue our config. I've already got a base config on R1. Remember, on R1, if I go back out here to R1, if I do a show run, we've got some configuration. And remember, I pointed this out earlier. I've saved it. Notice I've got a name server configured. I've got gigabit 0/0 set to use D8CP. Let's say, yeah, I want to save all that. And let me prove it again. I'll do a copy, run, star. I have saved my configuration. So here's where people run into a problem. They say, I'm going to export this and to a YAML file, because earlier I brought in that OSPF file and it remembered all of its configuration. So yeah, I just want to export this. So here's what they do. This is not what you're supposed to do, by the way. I want to show you what most people, or a lot of people, run into. They'll go under, they'll click the topology and they'll go under nodes. And under nodes, they see, well, look at this. There is this, there's this, actually, I did that too quickly. They go under simulate. That's what they do. They go under simulate and they say, oh, there's a download lab. That's cool. Let's download the lab. So I'm going to do that and show you what we get. I'm going to say download lab, and I'm going to say this is our CML demo lab, and I'll just save it. Now I'm going to open that up in a text editor. Let me bring up a text editor, and I want to show you the contents of that file because it's readable with a text editor. Let's see here. I just opened that up in a different window, and I'm going to open that up in a text editor. I want to say open with text edit, and I'm going to show it to you. Here it is. Let me get over to a different window. Windows active right now. There we go. Let me bring my text editor over and I'll just show you what we got. I'll make this a little bit larger for us. But as we're looking through this config, notice we've got configs for our different nodes. Here's the, let's see, there's our switch. Let's look at our router. Here's the router config. There's the label we gave it. But as we're looking through the config, I don't see anything under gigabit 0/0. I don't see anything that says, here's our name server. This looks kind of like default settings. It didn't seem to remember anything. But you saw what I did. I mean, I went in here. Sorry for all the scrolling. I got a lot of windows open today. I went in. I said, download the lab. Why did it not preserve my configuration? Because I saved it. This is not obvious. Here's what you got to do. You've got to go first over to the Nodes tab. Let's go over to Nodes. And I'm going to select all of my nodes. I do that by checking this top checkbox. And I'm going to say, here's the magic that so many people miss. You have to say extract configs. This is going to update the YAML file that's going to be exported. I'll say I want to extract configs. And it says, all right, we've got 2 of 5 remaining. Let's wait till it finishes. By the way, if we were to look at look what it's doing real time. It's actually doing a show config as we're speaking. I didn't type in anything in that terminal. It was doing a show config for us. So it extracted all those. It extracted our configs. So now I'll go back to simulate. And again, I'll say download the lab. And I'll just overwrite the previous CML demo that I did. And I'm going to open that up in a text editor. And let's see if there's any difference. Well, there should have been a difference. Let's see here. I'm still not seeing it. Okay, let's do some troubleshooting together. This kind of stuff happens. Let's try this. Let's try this again. I'm going to go under Nodes. I want to make sure that we extract everything. I'll say extract configs. Give it time to do that. 1 of 5 remaining. Okay, now I'm going to go back to simulate. I'm going to download the lab. I'll call it something else. Maybe it didn't like me calling it the same name. I'll say CML Demo 2. We'll save that. And let me scroll over here. Let's close this one, which did not preserve our config. Let me bring over the one that I just created. I'll make it a little bit bigger for us. And let's see if it remembered any of our config this time. It's looking better. Oh yeah, there it is. The name server, that's something that we entered. IP address D8CP, that's something we entered. So this got our configs. So again, the step was we had to first go under nodes, select all the nodes, extract configs, then, and only then, do we go under simulate and say download lab. That gives you a YAML file that will then be reusable for you. So I hope you enjoyed that little tour of, I wanted to show you something that's kind of new in Cisco Modeling Labs version 2.1. The look and feel is different for one thing. The little meters are down here in a different spot. I haven't been getting as many error messages, which is a great thing. But one of the things I think is just kind of cool aesthetically is if I go under admin, it now supports dark mode. Look at this. I can click that little slider and it switches this to dark mode. I'm a fan. I don't know how you feel about dark mode, but I'm a fan of that. I think that looks really, really cool. So I may start using dark mode more often. But that is the demo, and we want to take some questions before we wrap up today.